So the test is going to be on Wednesday, April 11. So it's going to be 2 chapter 4 and 5 of this one and chapter 2 of the other one, right? Chapter 2 of the computer science book and chapter 4 and 5 on C++ book. Because we did, what happened to chapter 3? I guess it's going to be 3, 4, and 5. Let's see how far we can go with this. Okay, any questions before we start? No questions? Everything is good? So we are starting chapter 4 today, right? Okay, so today we're going to be talking about the functions. And the idea of having a function is for 2 things. One is if I have certain code that is repeated throughout my program, I'm going to put it in a function, I'm going to call it. The second part is I can take that function and move it anywhere I want to. So it's going to be portable. So for when we're creating the function, we have to be sure those conditions are going to be met. So anything that's going to be repeated, like your Roman numeral, maybe we should do that again in the with the functions. So we're going to talk about the top-down design, predefined functions, programmer-defined functions, procedural abstraction, local variables, and overloading functions. We're going to cover some of it today, and we're going to leave some of it for Monday. So top-down design. So when we talk about the top-down design, we're going to be creating some kind of a algorithm. So what we're doing about the top-down design is we are going to take the big picture of whatever it is, and we're going to break it down in a smaller and a smaller and a smaller. So let's say I want to create a program to do the, what is the one that you guys are working on? Give me a program. The green card. Then you're going to break it down to the smaller pieces. How are we going to go with the smaller pieces with that? Usually these things are going to be a little bigger programs. So eventually the smaller subtasks are tribal. For those who are talking, can you take it outside of this classroom, because I have some people that they want to listen to me, and when you're talking it's going to be interrupting them. You don't have to be here, you're an adult. So if you want to talk and you want to do something, just do it somewhere else, please. Thank you. So eventually the smaller subtasks are trivial to implement in the programming language. Not only that, we can give it to different people to do it. So it's easier to understand, easier to change. Remember, we are breaking down the whole big picture. So let's say one of the jobs I did was to create a security program for the airport. Then you look at that and say, oh, how are we going to do this thing? That's a huge task. We're going to write a program that we're going to check the passengers coming in, their background, where they're coming from, and all kind of things. Then you think about it, so that's a huge thing. But then you start breaking it down, then you get to the small piece and say, okay, all we're going to need to do is write a random number, that by that random number we're going to check the person no matter what it is. Okay, I can do that. So I'm thinking about how can I create a random number that every 100 we're going to check the person no matter what. See, sometimes you hear that, oh, there was an old lady in the airport, or there was a child and they were searching this person. Why did they do that? It's because part of that program was randomly pick up somebody. Doesn't matter what the number would have come up from somewhere. But that would be part of it. So if I know that one, I can write it, I can test it, I can check it, and I don't have to worry about any other part of that program. It's easier to change, easier to write, easier to test, easier to debug, easier for teams to develop. So we can have different, on that program we had 95 engineering working, and I would say only 5 of them were in the same place at the same time. So we had different tasks for different group of people that they were working. At the end, we would put it all together. Do you have a question?
I was just wondering, because when you program it, because not everything like where they are, what is the business, like what kind of information you guys showing.
Well, that's a challenge for the computer science type of thing. That for my company, the first company that I worked for, it was a consulting company. So they were sending us all over the place. And most likely any program we were writing, we didn't have no clue about it. And for the security airport, we were not allowed to know everything anyway. So we were given only the information that we needed to do our task. Because, some of the things were, secret and nobody should know about it and all those kind of things. So that was, on the other side of it is what? You're going to end up to working in an industry. So, for example, you're going to end up working in a hospital environment. Then after a while, you can learn about that environment. So it depends on where you got, where you're at. Then you would know. A consulting company, which was good for me because it was very challenging. We didn't know. We would go in, and then we would get the requirement. We would start reading the requirement. We had questions. We would ask the client about the questions, and then we would start writing it. We had to learn about the system before doing it. That's part of the project management, software engineering, that for those who are going to the computer science, they will take some classes in that. We don't offer it over here. I wish one day we would do it, but I'm doing a little bit of that in my 3B class, but not too much. Okay, predefined functions. So if they are available or we have it, we don't have to write it again. So we can use it. But somehow we have to bring the code inside the program, right? How do we bring the code inside our program? Libraries. So we're going to put the pound include on top of the program, and that pound include actually physically brings the code and insert it on top of our program. And if you want to read those codes, you can actually go to the library, the include directory, and actually open the file and look at the code. Because C++ is one of those programs, it's open source. You can actually look at it. So one of the functions it's talking about here is called a square root, SQRT, that is going to take a number which is a type double, and it's going to return a square root. So if that function is available, I don't have to write it. And potentially in a work area, I'm going to be writing some functions that's going to be available to other people to use it. So we don't have to keep writing the code again and again and again. So we're going to be calling that function. So that the square root is here. We're going to pass a parameter to it because it's going to take only one parameter, and we're going to use it over here. So this function is going to return a value over here for whatever the sales is. It's going to take the square root, divide it by 10, and put it in back in the bonus. So one of the things I was talking to one of my students in the morning class was, for us to be here, that is a computer science class, we have to think about making our projects or program more efficient, more readable. We have to put the comments in it. I have to go through the style part too. We got to look at the style part. Do you guys have your book, the C++ book? I want to look at, okay, I get back to that. Let me finish this. We're going to go back to that. I have to talk to you guys about the programming style, which is on page 94 on C++ book. We get back to that. Okay, so we are talking about the square root right now. So if I want to use the square root, I have to know which library it is in, and that the square root happens to be in CMath. So I need that pound include over there before I be able to use it. So the function call, I'm going to be calling it. I need the function name. I need the argument. How many arguments is going to go in there? So in this one, we have sqrt with the one argument, and it's going to return something. The POW is going to use two numbers. They have to be double. Some of you used that one in your previous assignment. If you haven't, maybe you should. That would be that problem with the pi. The POW would be helpful over there. So we have bunch of library. The reason that we have bunch of library is, who knows why do we have lots of library instead of having one and put everything in there? Different people write them. What else? Different purposes. So why can we all have it in one and just put it in there? Yes, it's going to be a lot of code. Well, a speed, with the size of the program is going to be huge. It's not the, yeah, remember, when you are installing something like Microsoft, it needs a lot of storage to put it, and it's going to use a lot of memory, because it's got to save some of these things in the memory. But when you're going with the Linux, it's much smaller, because, you know, we're thinking about these things. So, every time I say Linux, they say Linux. I say Linux, they say Linux. That's fine. Okay. I go with Linux. I'm fine with Linux. All right. So, all right. Let's get into this one now. So the pound include, we got to find out what it is. So if you have a lot of pound include in your program, what I do is I go back and I start deleting them and compiling to see which one I really needed. So if I have like 10 pound include in my top of my program, I start deleting one at a time and then see if I need all of them or not. Your compiler, some of them are going to be helpful to tell you which one you might not need. They give you a warning on that. So if you read the warning, in the warning is going to tell you that this pound include is not used or this variable is not used, and we have to clean those things up. We're going to talk about more about the using namespace later on. That is going to be used for some kind of objects that if you're using something that belongs to somewhere else, you have to use the colon. So if I don't have the using namespace, then I have to use colon to do certain things. And that's what we're using, that one. We're going to see more of that coming up. So other predefined functions that we have ABS, which returns absolute value. The return type is integer, and the argument is just one argument. And we do need cstdlib. That's a C standard library. The FABS, that's going to be the one for the float. So it's going to be using the same thing, but it's for the float. You have this in your book. That's just one table for some of these things. The easiest way, I guess, is just look it up in Google or somewhere to find out what the functions are and what library do you have. I haven't found any cheat sheet for this to see what library goes with what function, so you have it on the side. After a while, you're going to get used to it. I mean, certain ones, you know what it is. Certain ones, you have to look it up. So in here, what we say is the type of argument, type of a return. So this one is going to take a double, it's going to return a double. So it's going to be 4.0 and return something that's going to be 2.0. And the POW needs a double. For ABS needs a integer. LABS, FABS. These two can be helpful. That's for ceiling and floor. Ceiling is what? It's going to round it up. Floor is going to round it down. So what again?
Minus 2. Square root 4 also equal to minus 2.
A square root of minus 2? I don't know what's the square root of minus 2. What about it?
No, minus 2 to the power 2.
Oh, yeah, the square root of minus 2 is going to give you error? I don't know. Put it in, let's see. Yeah, it should give you error.
Suppose the absolute together, they are together, absolute and square.
You put absolute inside the square root. That's a good way. Okay, typecasting. Typecasting is if I have a one type and I want to translate it to another type. The most common one is what? We have a division and we are dividing an integer with another integer. So what is 6 divided by 4? What is 6 divided by 4? I have 1.5 over here. Any better than that? That is not the correct answer.
1.
Anybody else? Nobody has the answer? 6 divided by 4. 6 divided by 4 is going to give you 1. Integer divided by integer is going to give you integer. 6 divided by 4. I didn't say 6.4. 6.0 is different than 6. That's why we have to use the typecast if we want to do it. I see that in the programs all the time. You're doing the average and you're doing an integer divided by integer, and the result is going to be something that you are not looking for. So that's why we have the typecast. So we're going to do a static cast. We can do a double. So this is going to change it to the double. I guess some people are working on the project. This is what you need. A static cast. Inside of this, you're going to say what is it that you want to change it to. So if I put this one, whatever this total candy is going to change it to double. I can put over here to char. I can put it in integer. I can put it in anything I want. This is the one that's going to change it right here.
So between the arrows is what you're changing it to.
The data type.
Want to change.
Yes, that's correct. The old-fashioned way, we would put it inside the parentheses, and that's still the way I'm using it. I'm used to that one. Now, what's the difference between this one and this one? Why is this not working and that's working? Yes, so I am dividing an integer by integer first. So integer divided by integer is going to give me integer. And I'm going to take that one and I'm going to typecast it. So I have, what do I have? I have number of candy 9 divided by 4. I get 9 divided by 4 is going to give me what? 2. And I typecast 2 to double, it's going to give me 2.0. But here, I'm going to do the typecast on this one first. Number of people is going to be, let me do it, what is number of people? So I'm going to do 4.0. Now that I have 9 divided by 4.0, now I'm going to have a double. Remember, if I have a mixed, it's going to always promote to the higher one. So if I'm dividing integer by a double, or I'm dividing a double by integer, it's going to change the integer to double before it does the operation. So that's the time that's going to get 2.25. So either I'm going to change the numerator, or I'm going to change the denominator to double, and that's going to work. I don't have to do both of them. Yes, sir. Uh-huh.
Put a number in, it's an integer, and we want it afterwards change what we initialize. So we put a number equals static, cast double, and then now it would be.
Okay, that's a good question. If I do a static type cast, it's going to change the value of it, but the data type is still integer. If I put it back in an integer, what's going to happen? It's going to lose the decimal point. So where is it holding is important too. Right. If we do the right side first, and then we're going to put it on the left side. So I can do whatever I want on the right side, but if I force it to be inside the integer, it's going to lose the decimal point. Yes, sir.
Yeah, so kind of like the typecasting only stays in the little equation you're using it in?
Yes, it's just happened right there.
So after that, number of people will go back to being an integer value?
It does not change the number of people. It does not affect the variable itself. It's going to make it right now. It's going to use it, and that's it.
So, but candy per person will end up being a double? Because you already said it was going to be double.
Candy per person, I have defined it as a double over here.
So it'll still be double.
Yeah, I'm not changing any data type. What I'm doing here, let's say here, what I'm doing is I'm going to take this number of people, which is 4. I'm going to static cast it, so my 4 becomes 4.0. It's nothing to do, yes, right there. It's not changing anything on the number of people. It's not changing anything. So instead of dividing total candy by 4, I'm dividing now total candy by 4.0. Good questions.
Creates a new little variable for a second, just for that equation.
Temporary variable, yes. Yes.
Instead of doing the equation, could you just take the total candy by itself and make that a stack double? Then take the number of people by itself and make that a stack double, and then do a regular equation. So now, well,
Yes.
instead of do it separately, just have the two.
You don't need to do it, but that's fine. Yes. I mean, I have seen some people say, okay, now that I need to do this, I'm going to make everything double.
It's easier than just doing it.
Yeah, but that's a lazy way of doing it because you're using a lot of space in the memory if I decide that everything is going to be double. That's what I'm saying, the difference between the CS, that you have to think about those things. If I do not need double, I'm not going to use double. But if I'm doing any kind of a division, the first thing I'm going to ask, am I dividing integer by integer? And if that's the case, I have to be careful with it. So the old style, that's the way I'm used to it. I'm still sticking with it. It's less typing for me. I just put the data type in front of it, and that's going to force it to do it. And instead of typing all those static typecast and all those things, I'm just using that double into it.
So this works as well.
Yes.
You don't have to do the whole typecast.
No. You know what else is working? If I multiply it by 1.0. That's another way. Remember, if I have different types, it always promotes to the higher one. So if I take an integer and multiply it by 1.0, it's going to change it to a double.
Why don't you just do that?
That's what I was telling my students in the morning. I have right now 60 students in my CS2 classes between morning and evening. So between these 60 students, a lot of programs are going to be totally different. And the ones that are very similar, I know what's happening. So people write programs differently. Every single person writes different program. So when I see a program and it looks like somebody else's program, it is not your program. So that's very, very easy to say. 60 people writing program is going to be 60 different way of writing the same program.
Question.
Yes.
So it's kind of like if you needed an approximate value for something, you use the time cast, right? Like if it was distance and you needed to change it from an integer to a double, or you needed to display them both, you could use the type cast, right?
Well, every time you want to change a data type from one to the other one, you use the typecast. It doesn't matter, whatever it is. Hold on a second. Let me get his, and then I come back to you. Yes.
I was just wondering this question.
Same thing. Okay, go ahead.
Oh, so if you run your program with the typecast to change the data type, does it stay that way for the rest of the program?
No. I just talked about it right now.
Integer that it changes to a double typecast.
Okay, you are not changing the integer. You are just changing it at that time, that instance. You're going to use it, and that's it. So if I have a variable, let's say num, okay? If I have a variable num equal 4, okay? When I typecast this one, I'm not changing the num, I'm changing this 4 to 4.0. So I'm not touching this num at all.
But does it stay 4.0 for the rest of the program or just like
No, it's just right there at that time. That's it. So it's a function call, and that's what it's saying over here. It's just for that instance over there, it's going to take this 4 and it's going to make it 4.0. That's it. It's not going to be the rest of the program. And still, this num is integer, and still the value of it is 4 going forward. And that's what we're going to talk about, the function calls, because things before it and after it can be different. Good questions. Any other questions? So this is what you guys are going to do right now on a piece of paper, and I'm going to collect it with your name on it, and I'm going to grade it for you. For those who are listening to me versus the people who are not listening to me, let's see how far we can go with it. You need paper? On this one, don't worry about this x, y plus 7, just do this one. Don't worry about this x and y plus 7. Just do this one. Yes, 5 minutes. If you cannot do the first one, I think I should have the right to kick you out of here. No cheating, Danzo.
Oh, I let my book.
Just kidding. Pardon me? Yeah, just the answer of it, the value. Which one, the last one or the middle one? The middle one, just a number. Two minutes. What?
Like 5.8 if the rounds down, does it go to 5.5 or 5.0?
Going down?
Yeah. Like, does it go to the half? Does it go to 5?
No. All the way down. Yes. Yes.
But the 7 divided by the absolute, is that the integer or double?
What is 7?
7 divided by
What is 7? Okay, that's an integer. The 7.0 is double.
So the first one, just because you're saying E is double doesn't mean that 11 and 2 are double.
That's correct. We talked about this. What are you doing? What happened? You're supposed to do this.
Yeah. I'm trying to look for.
Don't worry about those things. Don't worry about it. No. I don't know where it come from. I think it was another equation that got mixed up over there. Just that equation. Minus b plus b squared minus 4ac over 2a. You remember those for factoring in your algebra class? Quadratic equation. You finish? What happened to the last two? Think fast. You got it?
Yeah.
On which one? Last question. What do you have? No, what you? Oh, okay. This is good. So do the other one. What was that? Somebody's water?
Oh, that's not.
Okay, sorry. Can you see anything over here? It's so close to you. Don't worry about this x and y plus 7. Just do this. One minute. This is programming.
The first one's the only one I'm not sure about.
Ah, you failed that one. I'm going to kick you out of this class. Anybody fail the first one, I'm going to kick you out. Should I collect it seriously? Should I collect it seriously? Okay, let me have it. Let me have your paper. Time's up. Don't worry about the date. Just put your name and pass it on. Yes. Don't worry about that. Which one?
X plus y, is it square root?
Yes.
X plus y,
What happened to the other one?
then half, right?
What half? Where did you get half?
Because it's going to the half, right?
What were you doing when I was talking about this? Where do you get the half from?
Yeah,
A square root is a square root. You're writing as a power. That's it? That's all I have? Jason, you're out. Jacqueline, you're out. Geraldson, you're out. Nicholas, you're out.
Oh, the first one is fine.
Go home. Christiana, you're out. Paul, you're out. Anybody listen to me? Oh, God. I'm going to go home. I'm out. Roshan, where is yours? Okay, 11 divided by 2 is what? 5. When you put it in a double, what's going to happen to it? 5.0. Why are you guys giving me 5.5, 5.35? What are you going to come up with those? Should I mention the name? I have 5.35. No, I'm sorry, I have 2.35. 2.35. What happened to this? What you guys did?
How would you do this for x plus y?
Okay, let's go over it. Let's go over this. So we have 11 divided by 2 is 5. You assign it to D, which is going to be 5.0. I have the best answer here is 2.35. And remember, the Math 9 was required for this class. Determine the value of POW. 2, 3. What is that? 8. Fab's negative 3.5. 3.5. So we're going with the POW 3, 2 is going to give me what? 3 to the power of 2 is what? What did you say?
Oh, sorry, 3 to the 9.
The square root of 9 is what? 3. 7 is integer. You divide it by absolute value, which is going to be 2. 7 divided by 2 is what? 3.
Doesn't absolute value output double?
No, that's F, ABS.
So absolute ABS outputs integer?
Yes. Ceiling. Ceiling is going to go up. So it's going to give you 6. 6.0. I will take 6 or 6.0. Floor is going to go down. 5.0. A square root of x plus y, right? That should be easy. Next one. Remember, 4AC, you cannot write the... I'm still getting students who write 4AC in the program. You have to have a star in there. 4 times A times C. We don't have 4AC. How do you write B2? Either B times 3 or you're going to do POW B2. 2.0. And then you're going to do a square root of that. We have unary sign for negative. So you can put the negative in front of B. You have negative. You can put a negative sign in front of something. Or you can say negative 1 times that. Doesn't matter. And you divide it by 2 times A. What about this? It went outside the paper. Okay. I got to do this more often. I like this. Get your attention. Now I have more things to grade. Too much to grade. 90 programs every week. Okay, now it's your turn to create your own function. Now we're going to create our own function, and that's what we're going to be doing right now. This is something that you want to pay attention because it has some areas that you might not be familiar with. Danzo, instead of talking, you listen to me. And then you give me a wrong answer over there. Okay, so we have a syntax for the function that we have a return type. We have the function name and parameter list. So we are talking about defining a function. So we need 3 sections for the function. We have a declaration, we have a definition, and we have a function call. The old-fashioned way was the definition would go on top of the program. So if I was looking for a main, I have to go all the way to the bottom of the program looking for the main. But the new way of doing it, I'm talking new year like 20 years ago, we're putting the functions on the bottom of the main. That's outside of the braces of the main. For that, compiler doesn't know what function we created. Remember, compilers go one line at a time. So when it goes to the program and I have a function call, it doesn't know what I'm talking about. So for that reason, we're going to get something like this on top of the program. Remember, we ought to go with the comments inside the program. You have to have a comment on top of your program explaining what your program is doing. You have to have the comments under your function to tell us what is your function doing. I'm going to start deducting points for those things. If you don't know about those things, it's section 2.5. That's chapter 2, section 5. It talks about these things. We have to have a comment on the top of your program. You have to have a sample run on the bottom of your program. You have to have comments inside your program. Okay, so we have declaration on the top, we have definition on the bottom, and we're going to be calling it. So when we're talking about the declaration, it's going to be return type, name of the function, how many arguments do we need, the types of argument, and formal parameter name. What is the name? So example here, oops. Example here is I have double total cost, int number par, double price par. As far as the compiler cares, it doesn't care what name you're putting over here. It just wants to know what data type is it, so when it goes inside the program, it knows how to match it up. Compiler is trying to help you with your grammar of your code, so it needs to know what data type do you have in there. And then we have the comments. It explains in English. What is it doing? So I have declaration on the top. I have definition on the bottom. On the bottom, I'm going to say what is exactly the codes that's going to be running with this function. So if I call this function, it's going to jump to this section, and it's going to start doing these things. So I have parameters. That is the variables coming into my function. What is coming into my function is these things coming into my function. I can have local variables. These are variables that have been created here inside here. As soon as I hit these braces, this local variable is going to go away. We're trying to make this portable. So this constant double tax rate is going to be inside of here. So if I move this function to another program, it's going to carry this with it. If I define this on top of my main, it doesn't have it here. So we have some local variables we're defining here. We're going to do our calculation, and then we're going to return. In one of my jobs, the QA was asking us to create a variable for this and return just the variable. The QA didn't let us to do these kind of things. But anything inside this parenthesis is going to return back. So when I call that function inside, okay, let me talk about this return. So we have a return expression. So we can put the calculation or just one variable, and it's going to return the whole thing. So all this is going to be calculated, then it's going to return. So if I say double bill equal total cost, that's function call. So I have a declaration on the top, definition on the bottom. Inside my program, I'm going to call that. So when I call this, it's going to, first, when I'm compiling it, the compiler is going to come and look at it. It says there is a name here. I should have it in my declaration on the top. It's going to check this number and this price to be sure that the data type is the same as what I have in my declaration on the top. Then it's going to check this one for the return. So it's just checking it to be sure I have the correct ones. Now, when I'm calling this, it's going to go to that function. It's going to start executing every line of that function using these variables. And then this whole thing is going to be replaced by the return that I have for that function. So that's going to be replaced with this. From here to here is going to be taken off, and that number is going to be replaced over there. So this is called declaration. This is called function call. This is my actual function. Once again, on the top, it doesn't care what we're going to call the label. But because I don't want to type anything, I just copy the first line of my function, copy it, paste it over there, put a semicolon at the end of it. And of course, the comment of saying how this function, what is this function going to be doing. Then we're going to define the function over here. What is this function going to be doing after the braces of the main? Remember how many times I said after these braces. And now we're going to see how many people are going to put it inside. Then the function call is going to be inside the main. So three things: declaration, function call, definition. So when we're calling this one here, it's going to actually jump over here. It's going to take this number, it's going to put it here. It's going to take this one, it's going to put it here. It does not matter what you call these things as far as you're using that one inside here. So number in this book, the convention is using underscore par to say that's a parameter for this function. Yes, Danza?
I know you said it doesn't matter, so you can use the same number and price as you use in the bill. And when you use the function call, those integers, the number and price, you can do the same thing there. Instead of using number and par, right?
Yes, you can do the number here and the price over here. What your book is trying to do is trying to tell you that it doesn't have to be exactly the same thing. Because sometimes we get confused that we think it has to be the same thing, and when we take this one and we move it to another program, which instead of number and price, they're going to have integer and amount. Yes. So that can change. What we're trying to say over here is it's okay to change it over here as far as the type is going to match. Remember, this is the int, this is the double. This is my first number, this is my second number. If I switch these two, then it's going to use that one as a number, you're going to use that one as a price. Because it's going to match it up with this one. It does not know what you're talking about over here. It's just going to use it over here.
So as long as the type is the same.
It's just going to use that one.
For your variables, but it's going to use the order you put them in.
In the order, that's correct. So it's going to use the order, not the name.
The order and the type, as long as the type's the same.
Correct. So even if I had the here number and price, if I switch it over here, it does not switch it over here. This number has been defined right here. It's been read through the keyboard, right, from the user. Price, same thing. When I'm calling this function, this number and price is going to be copied in. It's not going to be used the same thing. It's going to make a copy of these things and pass it on. So when I'm finished with this one, the number and price is not going to be changed. Doesn't matter what I did with the number and price right here. This one is going to guarantee that this number and price are not going to be changed inside that function. That's the same concept with the typecast. Because it's using a function for typecast, the actual variables are not going to be changed. They're going to make a copy, it's going to be used, and it's going to come back. Any questions on this code? Sample run, remember the sample run has to be in the bottom of your program as a comment. Every program you turn in, it has to have a sample run and comments on the top. Sample run on the bottom. If you don't know how to do the sample run or paste it to your program, let me know. So what I was saying is called call by value. That means that your variable is not going to be changed. If I want to change it, there is a way to change it. But right now in this ones, we are just going to be using the first argument is used for the first formal parameter. It does not matter what you call it. The second argument is going to be used for the second parameter, and so forth. So in this case, I have a price par, I have a number, I have a number. So when I call this function, it's going to come down here into this one. It's going to get the number and the price. The number is 2, the price is 10.10. It's going to take those two. It's going to go through this one. It's going to do all its calculation. It's going to calculate this one, that's just 21.21. It's going to return. So this whole thing is going to be replaced with 21.21. Where is this function declared? What is the declaration of this function? The bottom is definition. Declaration is supposed to be on the top. We don't see it. It should be here somewhere.
Declaration is outside of the name as well.
Above line, yes. So the declaration should be what? Double, total cost, int, comma, double. So I would copy this, put it on top of here, put a semicolon at the end. The key over there is you have a semicolon. The key over here is you do not have a semicolon. No semicolon here, one semicolon on the top.
Professor,
Yes,
why not just have that whole thing on top outside of the name?
that was the old way of writing. Then your main is going to be disappearing, or basically it's going to be hidden. So that is doable, but it is not. It's not a good design programming. That's the way it was when I was first writing programs. We had to put it on the top.
So you declare it outside of the
Yes,
semicolon.
semicolon. So alternative declaration lists formal parameters, lists types of formal parameters, but not names. First aids a description of the function is comment. So for this, I could just put int and double. That's all it cares. But once again, I just copy it and paste it. It's much easier for me to do it that way. That this is sufficient. I don't have to have names. This is the declaration. This is the one on the top. Okay, so in this case, I have a char as a return. I have grade, int received par, and int mean score par. So when I do the int received equal 95, mean score is 60, then I have changed these things because I put the minimum in the first one and receive on the second one. So the program doesn't care. It's going to pick up the first one. So if I put this order wrong, what's going to happen? It's going to take the receive for a minimum score, and it's going to take the minimum score for a receive. It just goes with the order. It does not care for the name. That is my declaration over here. That is my function call. I need declaration, function call. What else do I need? Definition. This is my definition right here. My sample run. So, more about the function definition syntax. Variables must be declared before they are used. So we can define it when it's coming into it, or we can define it inside. And the typical way is you declare it above everything else. So you would have a section for declaration of your variables, and then you're going to use the execution inside the definition. Remember, your main is actually a function. You actually been doing a function that was called the main. That is a function that you were using all along. So we would have a type return. We would have the name of the function. We have the parameters in here, and we're going to declare all variables, and we're going to have executable statements. This doesn't have to be this way. This is a convention of doing it. That's what it was asking. We could put the definition on top of the program. Then you would not need a declaration. or you would put it in the bottom. This is the convention right now, the style of programming that we're putting the. Remember, in real life, you're going to have lots of this function. So if you have 55 function on top of your program, finding your main might not be easy. So placing the function declaration prior to the main function and the function definition after the main function leads naturally to building your own libraries in the future. Remember that pound include that we have on the top, what is it doing? It's just going to get that code and put it on top of your program. So you can potentially write those functions, put it somewhere else, and bring it in as a pound include. We can have a Boolean return that's going to be true and false. We can use our function inside the if statement. So this is going to be returning true or false. So we're going to be using the if, and then I'm going to call the function inside the if. What is this? Which one it happens first, and or? Well, in this case, because it doesn't want to confuse people, it's putting the parentheses around it. So I have this parenthesis that's going to end right here, and I have the other parenthesis that's going to end right there. So which one is going to happen? And is always going to be before or anyway, but in this case, because it wants to be clear, it's putting parentheses around it. So we're going to do this and is going to return what? True or false, right? We're going to take that one and we're going to OR it with this one. So this is the one that we're going to check for the 0. Remember, when you have a division, you're not supposed to divide it by 0. So we're checking it to be sure it's not a 0. One more time for you. I'm going to collect it again. More work for me. Gee, it's the only way you can guess you guys do something, huh? So this is harder than the previous one. I'll give you 6 minutes.